Hello everyone. Today we are moving on to the next part of magnetic effect of electric current, that is magnetic field due to current in a circular loop. So I have drawn a circular loop here. The very important thing that you have to understand here in the diagram that is given in your textbook is the orientation of the circular loop. So just think about it. How is this circular loop oriented? So I may help you for this. Here we consider that there is a point X behind the board where the current is coming from behind the board, and in this section of the circular loop it is facing you. Then the coil is like this, perpendicular to the plane of the board, and in this area of the loop or in this part of the loop the current is going into, and it is going behind the board, and it is going out through a point Y. So once again, if the point X and Y are behind the board, from X the current is coming, then in this particular area of the loop we consider the current is coming towards you, then the loop is oriented like this, then it go into the plane of the board. If we understand this diagram like this only, we can explain the magnetic field lines that is drawn here. So let us consider a circular loop consisting of so many small elements. Can these elements be considered as small straight conductors? Of course. So let us consider two diametrically opposite elements of this circular loop. So the circular loop is like this. So one element here can be considered to be a straight conductor, but it is facing you like this. So the element is like this according to the orientation of this pen. So when the current is coming out through this straight element, how can you find the magnetic field? You can apply the thumb rule, or what is it? When the current is coming like this, we will place our finger like this so that the curling of fingers is like this. So the anti-clockwise direction of the magnetic field lines are explained. I hope you understood it. And let me ask you a question. Where is this magnetic lines drawn? It is on the plane of the board because the circular loop is perpendicular to the plane of the board. So once again, the current is coming, and through this element it is facing you. The current is coming towards you, then it is going out, then going in, right? So in this element the current is coming outside. When we apply the thumb rule, what happens is that the thumb is facing towards you, that shows the direction of the current, and the curling of fingers is the magnetic field lines of this element. Then the current is coming out, then it is going into the plane. Into the plane means the current element is faced into the plane of the board. So when we apply the rule, how will be like this? My thumb is going into, the current is shown into, and the magnetic field lines is in the clockwise direction. So I hope that the magnetic field lines due to two elements diametrically opposite is explained by the diagram as it is drawn in your textbook. So what happens when the lines move towards the center of the loop? Almost it will become bigger circles, and at the center of the loop it will become almost a straight line. And here in this diagram it is marked, here there is a north and here there is a south. How will you feel that it is north and this is south? So please understand, the coil is like this, right? And the current is running like this. For a person standing here, you have to understand it. I am moving my hands in the anti-clockwise direction. But a person standing at the other side of the loop here may appear that the current will appear that it is in the clockwise direction. So children, you have to understand another point. In a circular loop, when the current is appearing in the clockwise direction, it forms the south pole of the loop. And when the current is appear to be in the anti-clockwise direction, that forms the north pole of the loop. So once again, going back to the diagram, I have already told the current is coming out of the plane of the board. It is moving like this and it is going into the plane of the board, right? So when I look from here, when my hand is moving like this, what is it? It is in the anti-clockwise direction. So this side is the north pole of the loop and the other side, the person looking from other side may feel that it is his clockwise direction, and in this side it is his anti-clockwise direction as I feel. So if it is in the anti-clockwise direction, this side become the north and the other side become the south. Hope that the north and the south written here in this diagram are easily substantiated. Next, the other point that you have to notice, we have to deal something about the magnetic field at the center of the loop. The magnetic field at the center of the loop depends upon so many factors. If a loop is given and there is a magnetic field at the center of the loop, the magnetic field at the center of the loop depends upon the current passing through the coil, then the number of turns of the coil, and inversely proportional to the radius. If radius increases, magnetic field at the center of the loop decreases. When here there is a single circular loop, if there are n loops, n turns for this loop, the magnetic field at the center become n times. For example, the magnetic field at the center of a coil having one turn is x. So if the coil is having 100 turns, the magnetic field at the center become 100x. That also is given in your textbook. When the circular loop is having a single turn, the magnetic field, suppose it is x. If it is having n times, n turns, the magnetic field at the center will become n. Once again, to sum up, the magnetic field at the center of the current carrying loop depends on the current. When the current magnitude increases, the magnetic field at the center of the loop increases. Then, when the number of turns, the circular loop may consist of 100 or 1000 turns. That much times the magnetic field increases. And when the radius of the loop increases, the magnetic field at the center decreases. And also, when we consider the magnetic field at various positions on both sides of the loop. So when I stand here, the magnetic field will be more. Then when I move backward, the magnetic field becomes less. So if there is a circular loop like this, and this is the axis, one point P is here with 1 centimeter and another point Q is there with 2 centimeter. Somebody may ask you a question, at which point the magnetic field due to this loop will be more on this axis? The magnetic field will be more on P and less in Q. And when the distance from the center increases, the magnetic field decreases. Hope you got the point. See you in the next session.